Alright, for this one they're coming up with this, and it's actually an ellipse. They found that this was an actual ellipse, I guess. But if you know anything about an ellipse, we know that it's a lot like a circle, except for when we have two pieces on this side, they're called, they're going to be perpendicular to the two farthest pieces. So the max and min over here, and the max and min over here, the highest point of the ellipse, right? They're going to create this perpendicular, okay? And in essence, then is going to create this kind of isosceles triangle, right? And, but more than that, all they're really asking for is that if this is in scale, right, that this Mars rover was going over Mars and it's saying, okay, this is a good spot for a landing strip. Now let's see how much land there is to, would it be sufficient to land on, okay? And when you look at it's 1 centimeter is the same as 9.4 kilometers, okay? It doesn't really say how many kilometers it takes for them to land, right? I would assume it'd be similar to a landing strip on a for an aircraft, right? Since we land the shuttle on a similar landing strip, right? But that's a perfectly smooth landing strip, right? And not sure how smooth this is going to be, so I'm not sure. You might need to take into effect that it could, like planes that land in the bush, take a little bit more space to land because they're bouncing more. They've got less grip to slow themselves down, right? So I would assume that the tires braking would have less of a slowdown on rough terrain than on a nice smooth asphalt. Does that make sense? So they're going to need more space, obviously, I would think. And because you're talking about a spaceship trying to land there, I would think you'd need a little bit longer than an aircraft would need. But nevertheless, it should give us a good idea of, is this a long enough space? So we take a look, and if you measure with your tool, your ruler, right, you'll find that this is a 1/2 centimeter. Looks a little bigger here because I'm obviously blowing it up. But in your book, it's a 1/2 centimeter, and this is 5 centimeters. And so what we want to know is, well, how big are those two strips? How big are they in reality? And so we know that that for every 1 centimeter, it's going to be 9.4 centimeters or kilometers, right? So for this one, it's not too hard. Can you tell me how much? How many kilometers that would be, just off the top of your head? Can you tell me what NP would be in kilometers? Jordan?
1/2 centimeter?
Huh?
The 1/2 centimeter?
So the 1/2 centimeter. So Jordan, how much would the NP be in kilometers? If 1 centimeter is 9.4, how much is a 1/2 centimeter?
I would say 4.2.
4.7, close with the 4.2. You were thinking 8.4 in half would be 4.2, right? But the 9.4 would be 4.5 plus the 0.2, so 4.7. Same idea. right? 4.7, good. All right. So that was pretty easy. So what did we do to that? How did you figure that out? Calculator? Great.
I just guessed.
And so you just guessed?
Yeah.
And you used a calculator? How did you plug it in your calculator? Huh? If we take a look at it, this is to this, right? As this is to that. Let's look at that again. It's proportions. Okay? So 1 cm is to 9.4 kilometers. Right? As a half cm is to an unknown kilometers. Right? When we do it this way, it's like, wait a minute. I'm not sure how that is going to work out. Right? Because then kilometers and centimeters are canceled out and all this stuff. And when we're trying to do conversions, right? We want to take the conversion and say, I know that this is either 1 cm over 9.4 km, or it's 9.4 km over 1 cm, right? And then what I want to do is multiply it by whatever one I'm looking at. In this case, it's cm, right? And I want to get rid of the cm, right? So if I multiply this times 1/2 cm on this one, then the cm's cancel and I'm left with km. And basically, like you said, 1/2 of this, which was 4.7 km. Okay? Now what if I do that with this guy? It'd be the same thing. 9.4 times 5, right? And this would give us 45 plus 20 or 2.0. So 45 plus 2.0 would be very good, 47. Okay. There you go.